Alright, hello everyone, my name is Timothy Lee Grant and welcome to another video of Leetcoding. So, what problem are we going to do today? I don't know, let's pick it out. So, what should we do? Let us try I don't want to do sliding window. Last time we did sliding window. Let's try a tree. Let's do a tree. How do we feel about that? Okay, so we are going to be doing an easy. Easy. So what is the next easy one that we see that we haven't done yet? Oh my goodness, we have done a lot of these easy problems. We've done that one as well. That one as well. Okay, here we go. All right, and I can make myself a little bit smaller. So let's get going. Number 530. Minimum absolute difference in binary search tree. Given the root of a binary search tree, return the minimum absolute difference between the values of any two different nodes in the tree. Okay, so we're given a binary tree. We're given the root, which has a binary tree. And what do we want to do? We want to return the minimum absolute difference between the values of any two different nodes of a tree. So I guess we just need to, record the values of each node in the tree, and then, oh, I see, yeah, I see how this is going to be a little bit more difficult, because, all right, so 1 and 2 are the closest to each other, and 2 and 3 are also closest to each other. So this value here is the absolute value of their difference is 1, the absolute value of their difference is 1, the absolute value of their difference is 2, absolute value of their difference is also 2. Oh, but a binary search tree, the closest neighbor is actually going to be one of its children. So I was thinking I was going to create some kind of list, go through each node in the binary tree, and then I was going to iterate through that list and take the difference, like that would be an O of n squared. So for each element, I was going to take the difference between each element and find, okay, well, is there a lowest distance? So, like, for example, I have here a list, and I would traverse through the tree, and I would get 1, I would get 2, I would get 3, I would get 4, and I would get 6. Kind of like this. Then what I was planning on doing is doing an O of 2, or an O of n squared operation, where for each of these elements, I check what is the difference between here and here. It's 1. What is the difference between here and here? It's 2. And I would have some global minimum value. So I would say, okay, if this difference here is less than our current global minimum, update the minimum. And then I would do that for each of these, right? And then I would move to this one and say, okay, what's the difference between here and here? It's 1. Is that lower than my minimum? Yes or no? If it is, update it. Then here and here. See, that was kind of like the brute force method that I immediately was like, okay, that's what I'm thinking about. But because this is a binary search tree, I think I can utilize the properties of it. And what I mean by that is I know that its children are going to be the closest in proximity. So for example, this node is not going to be closest to this node. This node is going to be closest to either its parent or its child, right? So this node is either going to be closest to the parent or its two children. Now this node is not going to be closest to this node because it's going to be closest to its child, or this child. Okay, so how can I actually do this? Let me see. So def traverse node, okay, and then I want non-local, and I want that to be current min. Okay, so now I want to create that current min. So current min is equal to I wish I could just do infinity. Maybe I can just do -1. And notice, -1 is never going to be a valid minimum value because we want to take the absolute value between each of the nodes. So what is the lowest possible value that this current min can be? It can be 0. For example, if this is 4 and this was also 4, then we would say, okay, the value would be 0. 4 minus 4, 0, that's the current min. So this current min can never be -1. So I can use that kind of as a flag to trigger and say, hey, if it's -1, we haven't set it yet. And then based off of that, we do what we have to do. All right. So now I have that current min. I also want to just, if not root, what happens in the case that we don't have a tree? What do we want to do? Like, are we guaranteed to have a tree? The number of nodes in the tree is 2. Okay, so we are guaranteed to have at least 2 nodes in the tree, which is important because otherwise it's kind of undefined of what we do in that case, because there is no difference between 2 nodes. So what do I want to do? I'm doing recursion here, so I'm going to, from here, I'm going to pass in traverse and the node, okay? And then I'm going to return current min. So this is kind of the structure of what I'm going to do. I'm going to be calling this recursion function, and I'm going to be doing a search on each of the nodes recursively. And then during that time, I'm going to be doing something to be able to check the difference between these current mins, okay? I don't quite know what I'm going to be doing in that case, but I'm going to be doing something. And I'm going to be updating this current min, okay? Then I'm just going, once this finishes, it means that I've visited all of the nodes. So I'm going to return, and this current min is going to be the lowest value, absolute difference between any of the 2 nodes. So in recursion, we always need base cases. What's the base case? If not node, return. We just return. Okay. Otherwise, we do have a node. What do we want to do? I guess we calculate the value. So I also need parent value, okay? So I'm going to pass that in, no root, not node, root, and then root dot val. So I'm accessing the root's value. That's going to be the parent. That's not actually, because if I do that, the parent, because if I do it the way that I'm thinking, this is going to call here on the root, And now the root is going to think that that its parent is the same value, and then it's going to set the minimum value equal to 0 each time, and we done goofed. So, how do we rectify that situation? Well, we can't. Maybe I don't do the parent, and I only check the children. Okay, so now I'm at the root, and I'm going to check the value between myself and my child, value, and my child. And then if there is a case that my current difference is smaller than the current minimum, I want to update. So let me do that. So first I need to check if I even have a child, right? So if node dot left, then check left child difference, okay? Pass. If node dot right, check right child difference. And now we also want to go down and do the recursion if there is a child. So let's first check if we want to update. So if current min is equal to -1, or let's check the difference. So left difference equals what? The current value. So I'm going to take the absolute value of what? Of my current node. So node dot val minus the current node left child left dot val. So the current node's left child value. And we know that the left child exists because we just checked it right here. If it doesn't exist, it's null. Now, I first want to say if it's equal to -1, I want to update it no matter what value this difference is. If that's the case, I want to do what? I want to set current min is equal to left difference. Okay? What's the other case that I want to set it? If the current min is larger than left difference. Okay, if the current min is larger than the left difference, then we also want to set the current min to be the left difference, right? If this value here, 2, let's actually say this is 2, and now we update current min to be 2, okay? Because from here to here, we say that the current min is actually -1, so then it hits and it sets it to be the difference between here. Now we're down here at this 2. So current min is now 2, because here's the difference between these two. Now I check my left child from here to here. What is the difference? It is 1. Now 1 is smaller than our current minimum, which is 2. So I want to update current minimum to be 1, because here's that. So that's what I'm doing here. So if it is either set to that flag that says, hey, current min, it hasn't been set yet, or if current min is larger than the difference that we just found, we want to update it. Now, once we do that, we want to go into the left child, right? Because we know that there is a left child, so we want to go in and explore that branch. We need to explore down to see its children. So we will recursively call that traverse node.left. And now we know that node.left exists, but we also have this base case that would catch it if it's not null, or if it is null. So actually, because of the way that we're setting this up, I don't even think that we need to do that, because we're always checking to see, like, is our child existing? And if it's not, we just don't even go there, right? Like, we come here to this 6 and we say, is there a child? No, so we don't call it. Is there a child? No, so we don't call it. And then we recurse back up because we processed everything in this function stack, so we come back up here. So now the right is the exact same thing. We're going to say right difference is equal to the absolute value of the current node value minus the node.right.val. Okay? Now, if current min is equal to -1, because perhaps we didn't have a left child, and this didn't run, right? This entire thing didn't run because we didn't have a left child. But if we have a right child, our current min could be -1. And notice if we didn't have this, it's never going to update current min because current min is -1. That's lower than the maximum lowest value that we ever could go. Okay, so it's this, or current min is greater than right difference. Okay, in that case, we want to update the current min to be the right difference. Okay, and then we want to traverse down that path of the right child to see all of those associated nodes. So traverse, and then node, the current node, right child. And I think this should work. Let's see. Oh, darn. Output is that? How is it so... How is that so big? Non-local current min. Is it not updating the current min? That's what I'm... Let me see. Print current min. Whoops. Print current min. Let's see about this. Well, okay, so it passes both the test cases, but why not this one? Well, one thing that I'm seeing is it only runs. It's only hitting twice. Oh, why would it only hit twice? Let me just get rid of that. Let me do this. Let's see how many times it hits here. Left. Left difference. Okay. And I'm going to print right difference. Okay. Let's see how many times it hits there. Should definitely be more than 2. It's 4, but that's not... Should be that many nodes, right? Where's the difference of 9? Here and here. Okay. So I am going to why is that failing? Okay. I'm going to try to figure out what I need to print to try to troubleshoot this. Is there some way to like there is a breakpoint. Do we want to do a breakpoint? Can I run this specific test? Like I just want to do this specific one. Use test case. Okay. Here. Oh, wow, that's pretty cool. I get a visualization. Hey, that's actually really, really helpful. Okay, 2, 3, 6, and then 1, 2, 4. Oh, I see what the problem is. So a binary search. Oh, okay, yeah. So remember how I was talking about how a binary search tree, it would never be this node down here because it's always closest to its child? Yeah, no, that's incorrect. Because look here, this node, everything to the right of it is closest to that one. So that completely invalidates my method of trying to solve this. That's nice. Um, is there some way that I could possibly have a there's someone that I could have a value that's passed down. But how would it know which value to pass down? I don't even know. So, looking at this, right, what I'm thinking is if I go left, I know that possibly there is a right value that's closer. All right, so right now, what I'm trying to think of is graphs. Okay, I have a tree. There are different traversal methods for trees. There's in order, post order, and pre order. Then there's level order as well. I'm trying to think, does one of those orders satisfy or conform to what I'm needing? And I can also choose, like, instead of just going left first, I could go right first. So I'm trying to think, like, is there something here? So let's figure out what is in order. In order, no, pre-order. Pre-order is you process the node immediately, right? I think so. Pre-order, you come here, you process this node. So 2, 3, 6. Process means what in this case? I'm not sure. I'm not sure right now. I'm just trying to think, is there anything that conforms to what I might be looking for? I'm taking something that doesn't fit and I'm trying to smash it, right? Like smash it into the problem. So, okay, so process, process, don't process, but then process. Okay. Process, process. So in that case, I'm just going to write this in the comments. In that case, we have we're processing what? We're doing 2, 3, 6. 2, 3, 6. Then we're doing 104. Then we are doing 2, 2, 7. Then we are doing 701. Then we are doing, and this was what we said, pre-order. Pre-order. Okay. Now let's look at in order. Okay, so this would be in order. In order. What would that be? Let's see, we come here, then we come here, and we try to come here, then we process this one, right? Before we go to the right. So that's 104. 104. Then we come here, we try to go left, we come up here and process this. So that's 227. Then we come up here, then we process this one. 236, so 236. Then we come down here and we try to process this. We can't. Then we come up here and we have 701. Then we come here. We can't process this. We have the 911. And then we try to process that and we're good. Okay. Now let's look at post order. So post order. So we're going to come here, try to nope, then come here, no, no, and then process this one. So 227. 227. Then we come up here, 104. Yo, I'm not seeing anything because I need to connect this one to this one, right? And that's not happening. So then it is, then we come down here, so then we have 911, 701, and then 236. Yeah, that. Well, I'm not sure. Let's go look at the answers. So we're declaring defeat. I couldn't solve it. I don't know. I'm not sure how to do this. But now we are going to try to learn a little bit about this. I want Python. It's all Java. Whatever, it should be fine. Because this binary search tree node is ordered, so minimum difference of any node in the tree will be calculated from two adjacent nodes. We will traverse the tree in order. In order. Again, how does that help us? Because, oh wait, these two are close to each other, right? Okay. I should have looked a little bit harder. But does that actually help me? Like, how can I... What does process in this case mean? Like, I'm not sure how I would tie those two together. I'm not sure. We will traverse the tree in order of nodes from smallest to largest using backtracking and tail recursion technique. Okay. The order of the tree traversal is left, root, right. Left, root, right. Okay. Because all nodes in the left branch are smaller than the roots in the right branch, yeah. For left branch, we are using backtracking because we need to traverse from bottom to top. And right branch is tail recursion. What? What is tail recursion? Because we only need to return the value when we reach the rightmost last node, which will help. Okay. Well. Okay. So we're declaring a min with the max value. So this is what I wanted to do with like infinity. But if root is equal to null, we return the minimum. Get minimum difference, which is a recursion call on the left. Okay. Previous, which what is previous? Where previous is just null. So this is like a global, not global, but like a... I guess in this case I can call it a global. Previous is not null. We just take the minimum of the current min and previous. Okay. I'm gonna actually just ask ChatGPT to correct my code because I don't know what this tail recursion, what that's even supposed to mean. So here is my code, but it is wrong. I see the issue. The logic of checking the minimum distance or minimum difference between the current node and its children is incomplete, as it misses the point of checking differences between all pairs of nodes in the binary search tree, and specifically calculating the minimum difference between them. Okay? To get the minimum absolute difference between any two nodes in a binary search tree, we can perform an in-order traversal. So it also wants in order. So right now, we've already declared defeat, but that doesn't mean that we can't learn anything. And furthermore, if we did get defeated, that actually means that we have the most potential to learn. Because if I was just to crank this out really fast and I already knew how to do it, well, there wasn't much learning to be done. But apparently now, this problem offers something that I didn't understand. And I'm trying to, number one, find out what I didn't understand, how I can rectify that situation, and how I can move forward going into the future. Oh, one of the questions which I have right now is what does it even mean to process? Like, how am I processing and how am I keeping track of everything? Okay. So, To get the minimum absolute difference between any two nodes in a binary search tree, we can perform in-order traversal. An in-order traversal of a binary search tree yields a sorted sequence of values. Okay, yeah, that's what I got, right? Like a sorted sequence of values. Now, it's not sorted in ascending order, it's not sorted in descending order, it is sorted in order traversal. That's the sorting, right? Okay. Does that make sense? By comparing each node with its predecessor in the sequence. Predecessor in the sequence. Okay, so that's how we are doing the processing, right? That's what processing means in this context. It is comparing each node to its predecessor. And what is its predecessor? It is the previously processed node. We can efficiently find the difference. Okay, so previous is none. So let me actually just, before I actually look at that code, let me just do previous is equal to none. None. Let's see if I can get this. Okay, so now what do I want to do? I want to check here if previous, no, do I want to set previous here? I don't think I do. Because I want to use previous. Yeah, I don't think so. So I'm going to come here. I'm going to try to find the absolute value. I might just delete this. I don't know. Okay, so I'm going to come here. What am I doing? How can I use this previous is going to do what? It is going to keep track of the previously processed node. Okay. And how is this going to occur? In order. So I'm going to do an in order traversal. Okay. So I first go left. So if, this is how we're doing it, right? If node dot left, then what do? We want to go left. So traverse node dot left. Okay? We're going to keep going left. Then we're going to process. So process. Okay. Then if node dot right traverse node dot right. Okay. So process. If, what do I want to do? If previous is equal to none, no, I don't think I want to do that yet. So I'm just going to assume that previous is not equal to none. And then later I'm going to try to figure out where to actually put that previous update. Okay, so I'm assuming previous is not none. So what am I gonna do? Difference is equal to previous minus node dot val, and this is the absolute value. So ABS absolute, okay, like this. Then now I want to update previous, right? I think so. So previous equals the current node's value, node.val. Okay, so I'm updating here. And I only want this to run if previous is something, right? So if previous, then, so if previous is null, is none, we don't want to update. We don't want to update. We just want to set it, okay? And now I need to check. So if difference is equal to -1 or current min is greater than difference, then I want to update current min. Current min is equal to difference. Oh, previous. Okay, so non-local previous. So it should have always done it if... Okay, fine. If not node, return this in order traversal. So we go left. So we go left. Yes. That's what I did. If previous is not none, that's the same thing. Then I update current min to be, yeah, that's the same thing that I did. Then I update previous. Then I go right. I thought that's what I did. I guess I have this blocker here, but isn't that necessary? I'm taking the min. No, they just did it slightly different here. Okay, well, we're going back to GPT and saying, can you only change the lines that cause the error? Leave a comment on those lines that caused an error that you changed. I mean, I guess I probably, I don't know, I should be able to kind of, look at this and understand why my code is different. I don't know. Okay, change from -1 to infinity. Well, that's not causing a problem, right? Like simplified condition. Like again, that's not causing a problem. Like it's not. But why does that cause an issue? I'm not understanding, like, where's the problem? If difference is equal to 1, to -1, then no, not difference. Current min. Current min. But I still got the wrong answer. What? Yo, I'm so confused. Yo, come on, man. Like, what? Why? No. No. Come on. Okay. Is this code correct? Code is almost correct, but there's still a couple of logical issues. It does not like the fact that I'm doing this -1. I think you can do it with a -1. Setting current min is problematic because a valid minimum distance is always non-negative. Yes, I understand that. And that's why I'm using it as a flag. And I want this flag to be triggered, and we're going to trigger it and check here if it is equal to 1. If so, we always update current min. That's what I want. It incorrectly implies that the smallest difference found so far is negative. But I'm not implying that. I'm just using it as a flag. Please keep my -1. Don't change it. Please keep my -1. Condition to update. Like, I don't want to do it that way. Because I'm being stubborn right now. Okay? I want to keep the -1. I am using the -1 as a flag because there will never be a case that current min is equal to -1. Therefore, I know if current min is -1 that the current min has not been set yet. Please give me a working code but uses this -1 flag method. Okay, please. I am being very stubborn because I think I can use this -1. Got it. I understand that you want to use -1 as a flag to indicate current min has not been set. Here's the update. Okay, this is getting promising. Current min is -1. Previous, okay. Now, we have this. We go left. Then we process. So if previous is not none, check if previous is set. Okay? So if previous so if this is the same thing, okay? Then I find the difference. update. I mean, this looks the same thing. This looks like the same thing. Let me copy and paste it in, because unless I'm not seeing it. Let me copy and paste it in, then run it. Okay, so apparently it wasn't the same thing. Like, let me go back. Again, I wish I could press a little button that says, like, because now when I have here, it's going to say solved, but it's not actually solved. And I don't want it to say solved. So, but anyways, I can come here and I can like load this one in, right? Like edit or copy to editor. Okay. So this is my one. So, what do we have? We have current min is equal to -1. Yep. Previous is none. Traverse, non-local current min, non-local previous. If node dot left, traverse. All right, process. This one is different, but I'm arguing that it does the same thing. Difference is absolute value between previous and node dot value. Okay, that's the same. If current min is equal to -1 or current min is greater than difference, then we update current min with difference. Yep. Then previous equals node dot value. Okay. If node dot right, then we traverse right. So the only difference was this. So if previous is not none, that seems to be the only difference. But okay, well, apparently it's not the same thing. Let me go and review the truth table. We are going to get to the bottom of this. So if previous, okay, so let me hashtag it. If previous and if previous is not none. So now, in this case, previous equals null. We're going to get what? False, and this is not going to trigger. No trigger. We get false, right? If this is none. In this case, when previous is equal to null, what happens? Previous is equal to null. Or to none. So it is equal to none. So this is false, so it doesn't trigger. So no trigger. Okay. Is equal to something. Okay. Then what happens? Triggers. Because now this is true, right? Like previous is equal to something. So now if previous is something, then what happens in this case? then previous is not equal to none. And it triggers. So therefore, the truth tables are the same, and by definition, that means that it is the same. But according to our experience, it is not the same. So the world is out of order. Oh, come on. I thought that if previous and if previous is not none, are the same. I even created a truth table, and it appears that the conditions are the same, and if the truth tables are the same, then they should be logically equivalent. But if previous is not none works, and if previous does not work. The confusion stems from how Python handles truthfulness and the specific types involved. While if previous and if previous is not none can often behave similarly, there's a subtle difference that can lead to unexpected behavior in certain cases. If previous checks the truthfulness of previous variable. Previous will be considered false if it is none, yes, 0, or an empty string, okay? All of these things, right? An empty set, an empty dictionary, an empty list. That's, okay, great. Or any other value that equates to false. Yes, like none, like none, like none. If previous is not none. Could it be that we're hitting a null? This explicitly checks whether previous is none. In your specific example, if previous will fail if previous is equal to 0 or any other value that is considered false in a Boolean context. If previous is not none, it will only fail if... Okay, so if I set previous equal to like 0, like for example, if there's a 0 value in here, I'm guessing it's like that null. Am I setting null? I'm guessing that I'm like setting that null equal to previous somehow, and then it's triggering it. And when I do this specific method, it's saying, is it explicitly none, N-O-N-E? And that's the confusion. Okay, well, on that note, I am going to end this video. Before I actually do that, I do need to put this into my little notebook that is failed Leetcode problems. So all of the problems that I have failed and that I need to not forget to perform, because right now it says solved, but we didn't solve it. I didn't solve it. I failed. I failed. But I'm going to come back to it. And I'm just noticing, like, I think my hair is a perfect representation of the experience with this problem. So, on that note, I am going to call it a day, and it's almost midnight. So, I am going to head to bed. So, have to hit work early in the morning. So, here we go. All right. Anyways, thank you guys so much for watching this video. I hope you guys have a wonderful day. My name is Timothy Lee Grant, and I will see you guys tomorrow with another Leetcoding video. Hopefully we will succeed. I don't know if we will, but we can hope. We will definitely learn something. That's the thing. I don't know if we will succeed, but we will definitely learn something.